Total indicator runout or eccentric runout is a common term in manufacturing round parts. Runout describes how much one surface varies with respect to a datum axis when the part is rotated 360 degrees. To manufacture high quality, high performing cutting tools, runout needs to be kept to an absolute minimum. Numerous problems arise when cutting tools are manufactured with runout. On end mills, the flutes and cutting edges become uneven, so when the end mill cuts, the chip load isn't shared equally by the cutting edges, which can lead to premature tool wear and poorly machined surfaces. Runout on drills can affect the performance and accuracy. If the drill lips are unequal due to runout, the drill can start to wander or drill out of round holes. On anchor machines, we can check the runout by loading a tool blank and rotating the A-axis headstock. Sometimes, if the collet or collet adapter are old or worn out or damaged, it can be difficult to get the tool blanks consistently running true. Anker introduced our tool runout compensation feature in RN34. The principle of tool runout compensation is that it utilises the machine touch probe to measure the runout of the tool blank and applies a compensation so the grinding actually follows the centre line of the tool blank rather than the centre line of the machine A-axis. The Renishaw touch probe records the runout at 2 points along the tool blank, allowing calculation of radial and axial runout.
Tool runout compensation is a purchase option and can be enabled within the Digitize eccentric runout operation. To enable the compensation, turn on Compensate, and if you want to apply full compensation, change the compensate type from end face to full. The compensated operations list below shows all the grinding operations that will have the runout compensation applied. There's some optional parameters to determine where on the tool blank or tool we want to do the probing. Usually it's recommended to probe as close as possible to the end of the tool and then further down the shank towards the collet, usually as far as you can go without having any collision issues. The feed rates and gaps can be configured to optimise the cycle time. And we can also decide whether we want to probe at 12 o'clock on the top of the tool blank or at 3 o'clock on the side of the tool blank.
Preformed tools with flutes can also be compensated by changing the selection from blank to preformed. In this case, the probing cycle will search for the flutes and probe runout behind the cutting edge, offset by the A offset for OD dig parameter. Preformed tools with only 1 or 2 flutes aren't eligible for full runout compensation. Only end-face operations will be compensated. 3 or more flute preformed tools can have full compensation applied to all grinding operations.
The runout digitizing operation can be added multiple times to the operations list, allowing the runout values to update with each probing cycle. This is particularly useful in scenarios where heavy grinding, such as flute grinding, might cause slight tool deflection, which affects the runout. For that use case, you might insert a probing operation before the flute grinding and again after the flute grinding.
The end result of using tool runout compensation is that the finished tool has essentially zero runout when it comes out of the grinder. We'll demonstrate this by performing a runout measurement on the Zoller Genius machine. Tool runout compensation takes a lot of trouble out of cutting tool manufacturing and gives a lot of assurance to the manufacturers, particularly for large batch runs and lights out manufacturing. It's simple to configure and a very reliable way to ensure that your tools are finished to top quality. For more information on tool runout compensation, check out anker.com, or for more in-depth training, check the Anker Academy training course on tool runout compensation. Thanks for watching.